Well, hello everyone, and welcome to multiple linear regression. We're going to start with the data and what the problem involves. So here we have gate receipts. In fact, let me expand that so you can see that really does say gate receipts. So we have gate receipts at a stadium, and this is how much they're taking in. Then in the next 7 columns, what we have are the expenditures on different forms of marketing. So that'd be TV, radio, paper, magazine, mail, web, and promos. And our goal is to find out which of these forms of marketing is significantly influencing the gate receipts in a positive way, and which are not. And then to then focus our expenditures, right? Provide management with something that could focus expenditures on the effective modes. All right. So what does it actually look like? Well, I'm going to skip all the way to the end. This is effectively the answer key, so that you can see. And peering ahead into the future, you can see that 3 of those 7 are going to end up being significant. Those are magazines, TV, and promos. And the other 4 are going to turn out to be not significant. And we can actually go back in time using this control panel so that you can see. I'll go back to effectively the first run when they were all in there. And now you can see that here we have mail, web, paper, radio, etc. What we're going to do is eliminate each one of these one at a time until we get down to these 3. And the way that we choose which one gets eliminated is we look for the one that's going to be in this fail to reject region, but the one in the fail to reject region that has the highest probability. And by highest probability, we literally mean closer to the middle. And as you can see here, for the first time round, it would be paper. So then if I run the regression again, taking out paper, you can see everybody else moved around a little bit. Now the one that's closest to the center would be web. If I run the regression again, now the one still left in the center is radio. And mail is actually significant, but watch what happens to mail when I take radio out. Okay, all of a sudden mail is no longer significant, and so I have to take it out as well. And there's my 5th run, and there we go. And now I end up with this. So you're actually going to do all of this. Unfortunately for you, you can't just go 1, 2, 3, 4, 5. You actually have to do the hard work in order to do that. But look at what this does for management. What it does for management is it basically tells them, look, spend your money on these 3. Don't spend your money on the other ones because you have no proof that the others are contributing to the bottom line. Okay, so with that in mind, let's go to the start file. And here we go. So, predict gate receipts. An analyst wants to determine which of the factors shown here significantly predict stadium gate receipts. The goal is to save money by targeting marketing expenditures in ways proven to work. Alpha is 0.05 or 5%. So the null hypothesis is that there's no significant difference from 0. All the population slopes, in other words, every one that we're going to put in here will end up being 0. And so that would be all the predictors are going to be 0. And the alternative is that at least one of them is different from 0. All right. Now we have to actually get a number to see if that's true. I mean, peering ahead, we know that it's true. But we actually have to do what's called the global test. And the global test is based on the F distribution. So this is a normal distribution here. But when we run the global test, we actually use a different distribution called the F distribution, which, as you notice here, is only positive. It starts at 0. And it also has a critical value. For this particular problem, the critical value is 2.46, the F value. So what we're going to look for after our first run is, what's our value for F? Is it bigger than 2.46? If it is, then that would mean that at least one of these was a significant predictor. So let's go down to our data and then call up the data analysis toolpack. Pick regression, and the Y range is going to be the gate receipts, including the heading. It bothers me that that doesn't say gate receipts. It should. Gotta lengthen that, make that row height bigger. Anyway, the X range is everybody else, including the headings. And the output range here is going to be way over here where it actually says run 1. So this is the first run. Click OK. All right, now I got a strange message that the input range contains non-numeric data. So it's upset with me, so I must have done something. Well, it's not that I did something wrong, it's that I didn't click this little box here that says labels. And therefore it was picking up the heading and saying, hey, the heading's not numeric, but this should take care of it. There we go. All right, now your next task is to reference from this run here. So this is just a bunch of equals. So equals, there's the R squared value, equals, there's the standard error value, equals, there's degrees of freedom residual, equals, there's the F value, and equals, there's the significance F, or the probability of F. Okay, so that F is 310. Remember, we were just trying to get bigger than 2 point something. So yeah, definitely bigger. And the probability of a number this big is like almost 0% probability. So we know that at least one of these predictors is significant. So equals the intercept here, and then carry that down. Now, I don't recommend that you carry it across, otherwise these numbers will end up having lots of decimals. What you do instead is you grab the first one, then it will be formatted correctly, and then you drag it down and drag it across. Then all your numbers will have nice formatting like this. Okay, now this spreadsheet is set up so that these numbers automatically feed this grid, which feeds this graph. So you see how the graph is populated because we ran the regression. And also up here, you get some more information. Here's some of the numbers that we got, including the F and the probability of F. And just a reminder here, all we were trying to break was 2.46. 310 is definitely bigger. So what we can say is, if the test statistic, because this is the global test, is beyond the critical value, so F is much greater than the critical value, and the probability of F is definitely less than alpha, because alpha is 5%, and the probability of F is effectively 0. All right, so we reject H0, and what we say is that at least one is not equal to 0. And yes, we can use at least one of these. In fact, it's going to end up being 3 of these to predict. All right, now we can't answer any of the other questions because these say after the last run, these say after the last run. So we've got to do some more runs. So remember, the second run, we eliminate the one that's closest to the center. In other words, the one with the highest probability or least extreme t-score. It's another way of saying the same thing. So t.74 is less extreme than negative 0.79, so paper goes. So the way that we get rid of paper is kind of clever here. First of all, let me stretch this out because it's really bothering me that that's not showing the word gate. There. What we do is click in that cell, and you'll notice that there's a formula here about the columns. We're trying to take out paper, which is column 4, so I'm just going to come into this formula. This is a spill formula that populates the whole thing, so this is really cool. All I have to do is take out the 4 and its comma, and now paper's gone. And then I can run the data analysis toolpack again. And the Y range is going to be the same because I don't change that, but the X range is going to change. It's going to be 1 column shorter, so I highlight it again, leaving out that last empty column. And the output range is also going to be different because now I want it to go where run 2 is, right here. Click OK, OK. And then I have to reference all the cells again. So there's the R² value, there's the standard error, there's the degrees of freedom. And you'll start to see some patterns here, like the R², even though we're taking out predictors, the R² is going to stay really high, which is kind of cool. And the F statistic, this is even kind of cooler. The F statistic is going to get bigger as the model gets more refined. It's going to be even more significant, meaning that we're really onto something. Okay, then there's the intercept. Copy that down. Notice I'm only copying down to here because we're 1 short now. And then same thing here. And copy that down. And copy across. Now, as far as who's next to eliminate, I can get it 2 ways. I can actually see it right here by picking the highest p-value, which looks like it's going to be Webb at 0.22. But I'm a very visual guy, and I like doing it from here. So I can see that Webb is the one closest to the middle. So that's the next one to go. So back to the data analysis toolpack. Change the formula to get rid of Webb, which is Webb is number 7. So click here, get rid of the comma and the 7. Webb's gone. Run data analysis toolpack. The Y range will stay the same, but the X range always reduced by 1. Highlight. And the output range is going to be for run 3. Click OK, OK. And then reference the cells again. Again, the R² is staying really high. Pretty much up there at 99%, which means this model is fantastic. Because 1 is the highest you can get on an R². It's 0 to 1. The standard error. Degrees of freedom residual. The F statistic keeps getting bigger. And its probability is still effectively 0. Then we'll pull these. Notice now we have 2 cells blank at the bottom. Grab the coefficient, drag that down, and then drag across. And now we can quickly look, well, who's the biggest number? The one that's going to disappear next is going to be radio at 0.16. But I like seeing it in the graph. There's radio, right? It's actually right now it's the only one still in the fail to reject region, so that one goes. Go to data analysis, back to regression. The X range now Oh, sorry, I can't do that yet. I didn't make radio go away. So radio goes away. So that's number 3. Okay, now I can do the data analysis toolpack. Regression. Highlight the X range. Change the output to run 4. Click OK and OK again. And then reference the new values. There's the R squared, still staying up at 99%. Notice we haven't, even though we're eliminating predictors, we haven't lost any predictive power, which is really cool. Standard error, degrees of freedom residual. Notice the degrees of freedom are increasing because we're removing the number of things that have to be estimated because we have fewer predictors. There's the F, which is getting bigger too, and the probability of F still stays essentially, I mean, it's such a small number that it's essentially 0. And there's the intercept. By the way, the intercept is the one and only one that you can't eliminate from the model. So when you're eliminating predictors, it's everything but the intercept. All right, now notice here that male jumped up to 0.08, so it's got to go. And you're probably wondering, how did that happen? Because in the last round, male was actually was significant, but because there's interactive effects, when you take a predictor out, sometimes everybody else shifts. It's called collinearity. Okay, so male's got to go. Let's first take it out of the data. It's number 6. Take it out, and it's comma. And then run the data analysis toolpack again. So the X range, and this is going to be our last run, fortunately. And the output range is going to be run 5. Okay, reference the R squared. Haven't lost a step there, which is great. Reference the standard error. Degrees of freedom residual. The F statistic is off the charts, and its probability is effectively 0. All right, now for our predictors, you've got the intercept. And then for the coefficients, down and across. And now you'll see that everybody is less than 0.05, so they're all significant except for the intercept, but the p-value for the intercept doesn't factor into this, so you ignore that. Looking back at the picture or the graph, you can see where I said we would be at the end, which is everything is significant. All right, now we're ready to answer the rest of the questions. So, what are we predicting? What's our Y variable? That's gate receipts. That's why I spell that right. How many predictors made it into the final model? 3. The more extreme the coefficient BI, the greater the likelihood of significance, since the t-score is BI divided by the standard error. Does this hold true in the data? So what we're actually asking is, are these values like these B1, B2, B3, are those much bigger values than the ones that we got rid of? Well, we can't see the ones we got rid of, so I'm going to very temporarily put them back. I'm going to put that back to 1 so that you can see, well, this one's 0.65, 0.20, 0.27, 0.21. So yeah, they're much bigger. Let's put that back to 5 so things don't get messed up. Okay, so the answer is yes. For the predictors eliminated, is their value assumed to be 0? Yes. It's assumed to be 0 in the presence of the other predictors. It seems odd that dollars spent on newspaper, radio, web, and mail would have no significant impact in the presence of the other variables. Is one explanation that those activities were just poorly executed in comparison to the others. So in other words, it's not saying that web advertising is bad, just that we don't do it well in our company. And so the answer is yes, and now we get all of those. All right, now, referencing the graph. For every dollar spent on TV, how many dollars can you expect to earn at the gate? So for every dollar spent on TV, your predictor, your multiplier, your B1 here is 357. So for every dollar spent, we expect to earn 357 at the gate. For every dollar spent on magazines, how much do we expect to earn? 224. And promos, we expect to earn 432. So that's our most effective vehicle, are the promos. Approximately, what is the raw positive critical value for magazine? So let's look at magazine. Magazine is here. So these are the raw values for each: TV, magazine, promos. So magazine, the positive raw critical value is about 1.56. It's the value that corresponds to 2t. It's actually 2.06t, but kind of close enough. So that's going to be the 1.56. The interpretation of the raw critical value for magazine is that if $1 is spent on magazines and the gate receipts changes more than $1.56, then magazine predicts gate. Otherwise, it's just sampling error. So that's kind of cool. In other words, you got to exceed $1.56 for every dollar spent on magazine before we're going to call it significant. And in fact, we were out here at 221, so we're definitely significant. So magazine predicts gate. Standard error is the sampling error. It measures the expected variability between a sample slope and its population slope. Are the standard errors different for each predictor? Well, yes, they are. The standard error actually is what you get at 1t. So here you have 0.81, 0.78, 0.66. So it's different for each predictor. And if I brought back the other predictors, you'd see that those are all different too. Yes. Okay. Now, a couple more things. We have here something called the prediction table and confidence in the prediction table. So what we're going to do is say, okay, here's our three predictors, TV, magazine, and promos. What if we spent $100,000 on each one? Right? What would our return be? And so the return is going to be just those two multiplied together. So this times this. And we can carry that formula down. And then our total return is going to be the sum of all those. Actually, including the intercept. So, and then let's sum this one too, so we can drag that same sum formula here. All right, so we would end up spending $300,000 and making $1 million at the gate. So that's pretty good, right? And it's much better than what we started out with. If I briefly put this back to 1, you can see that in the beginning, had we spent $100,000 on everything, we would have spent $700,000 and made the same million. So it's much better. Put that back to 5. Much better to spend $300,000 and make $1 million than spend $700,000 to make the same million. Right? But this isn't a perfect prediction. It has boundaries. It has a lower bound and an upper bound. So what we do is we take that number and we subtract from it 2 times the standard error regression. You're probably wondering why we kept doing that standard error regression every time. That's that number. That's this one that's just kind of been copied up here from the last round. And then, again, same number plus 2 times the standard error. And so what this is telling us is that we're going to make at least 993,000, 95% confidence, and maybe as much as 1,056,000. So pretty good. And let's see if we have anything left to finish. No, we got the badge, and we're good on this one, and we'll see you in the next video.